Good afternoon. Yesterday or 2 days ago, we were talking about the theoretical probability with what should happen. Today, we're going to talk about the experimental probability, what actually happens. So what's actually going on. So those results that we were just talking about, we're going to be using those for our assignment today. First thing we're going to do is say the experimental probability is what actually happens. So no more of what should, not a 50-50 chance of flipping heads or tails. It's what did I actually get? So experimental, you're doing the experiment. What do you get? So we're going to look back at yesterday's objective and we're going to fill in our numbers. So what were your individual results from flipping a coin 50 times? There were a few of us absent, so we're going to use somebody else's numbers. Kate, tell me what your numbers were for heads and tails.
25 and 25.
Okay, who did not have 25 and 25? Evelyn.
18 and 32.
18 and 32. So if you did not do the experiment with us the other day, we're going to fill in with Evelyn's results.
Okay.
So theoretically, we would get 25 heads and 25 tails. There were a few of us that actually did get that theoretical probability. It was also their experimental probability. But we saw that the majority of us did not reach the theoretical probability. So it can happen, but it's not likely to happen. The majority of people were just off a little bit. So instead of getting 25 and 25, Evelyn got an 18 and 32. So what were the class results from each of you flipping a coin 50 times? Oh, so now we need to add them all together. So
That's a bit of
somebody take out their calculator. Everybody take out your calculator. We're gonna do the, sometimes we add wrong, but we're gonna try to do it the best that we can. If we remember from our last objective, the theoretical, we would get 525 heads and 525 tails. So now, I'm going to go around each table and you're going to say what you got for heads. And we're going to add it up. Okay? So, yep, we're all using our calculator. I asked you to get your calculator out because I don't want just one person doing it because one person can make a simple mistake.
Okay.
Nope, there were 21 of us here, so if you were not here, you're not going to tell me a number. Okay, Evelyn. 18 plus
25.
25 plus 23 plus 25 plus 23
24.
plus 24 plus 25 plus 21 plus 24
Plus 25.
plus 25
Plus 26.
plus 26
Plus 23.
plus 23
Plus 27.
plus 27
25.
plus 25
Plus 20. Plus 32.
plus 32
31.
plus 31, you're not here,
29.
plus 29
25.
plus 25
20.
plus 20. What does that equal?
471.
So we got 471 heads. Did we reach our theoretical probability? No, because there were so many of us that were just off. Okay, so how many tails did we get? So we're going to go around again. Oh. Shh. Do we have to, if everybody actually flipped 50 times, that's what we're going to have to say. We actually flipped 50 times. We know that we had 1,050 flips. So we know that there was a total of 1,050 flips. So if 471 of them were heads, how many were tails? 579 were tails. So compare your results to the class results. which was closer to the theoretical probability? Were your results closer to the theoretical probability if you had 22 and 28? Or is the class results closer to theoretical probability of 471 and 579? What was that, Gus? Oh, proportions. So you need to think, was your proportion closer to the actual number, or was the class results closer to that theoretical probability?
Should I use weights?
You can, yes.
Oh, definitely my own.
So why do you think that the theoretical probability for just you might have been closer to it, but for the whole class, you were farther away from it? Why do you think, Hugo?
Because we had a smaller trial and we had a smaller experiment.
We had a smaller trial, a smaller experiment. Okay, we're going to keep that in the back of our head as we look at our dice experiment that we did.
No.
I'm like guarantee I might have calculated on how many dice rolls I did.
So, you need to write in your individual results from rolling a die 120 times. Who wants to offer up theirs for our friends that were not here? Emmett.
22, 18, 27, 9, 18, 26.
Okay, so fill in your numbers, and then we're going to,
Wait, ours?
fill in your own numbers from the last objective. This is for my friends that were absent. And then we're going to do the same things with the 1s, 2s, 3s, 4s, 5s, and 6s that we did with the heads and tails. Why do we have to do every single one?
Because it's not just that even two.
It's not just that even
We have to
two.
do at least 5.
Right. And it'll be quicker to do the 6.
Instead of adding and then 6.
So we're going to go around like we just did, but this time we're starting with our 1s. So everybody have your calculator out. 20. Plus what, Audrey?
22.
22. 20. 22.
25.
25.
19.
19. 14. 16.
19.
19.
17.
17. 21. 20. 13.
21.
21.
20.
20.
18.
18.
22.
22. 10.
20.
20.
15.
15. How many ones did we roll as a class?
374.
374. Let's do our 2s.
19.
19.
19.
19. 14. 18.
20.
20. 18. 16. 16. 21.
Oh, wait, no, 22.
22.
19.
19. 19. 15. 12. 20. 22. What was that, Gus? 17. 22.
25.
25.
15.
15.
369.
369 twos. All right, 3s. It's on the board. You can always just look up on the board. Okay, starting over with our 3s. 13. 19. Another 19. 27. 21. 17. 30. 23. 20. 20. 16. 24,
25,
25,
23,
23,
26,
26,
13.
13,
19,
19,
15,
15,
20.
20,
24.
24. What does that equal?
14.
error.
And this is why we are all doing it, because some of us punched in something wrong and we get an error and we don't want to have to repeat it. Yep, it happens. Okay, now our fours. 25, 20, 21, 9, 20, 21, 18, 24, 20, 25,
Plus 23,
23,
17,
17,
25,
25,
18,
18,
22,
22, 22, 18, 16, 20,
12.
and 12.
396.
Sorry, I heard two different numbers.
396. I said
396, thank you. Okay, cleared out. Fives. Evelyn got a 14, 20, 25, 18, 19, 16, 15, 26, 22, 16, 14, 20, 25, 21, 16, 24, 23, 32, 25, 17, 408. Last one, lucky number 6. So cleared out, lucky number 6. Good, but it's gonna go quicker. It's still Evelyn. This is more fun for me. Evelyn. 24. 20. 21. 26. 15. 29. 27. 20. 21. 20. 27. 20. 27. 21. 16. 21. 21. 25. 20. And 25.
446.
I'm sorry, did you say 446?
Yeah.
Okay, 446. Our theoretical results were what? What should we have rolled? Who remembers? Look back.
420.
420 if we had 21 students doing our rolling. So look at, oh friends, I'm recording. Look at the differences between our numbers and the experimental and our theoretical. Think back to your numbers. You rolled 22 instead of a 20. That's a lot closer to the theoretical than 374 to 420. So again, thinking about the differences that we had with the heads and tails, and that experimental with the whole class was a much bigger difference than the experimental by yourself. Aiden?
I added them all to
Yeah.
It's not all.
So why do you think our numbers didn't work out exactly? If we added 1s, 2s, 3s, 4s, 5s, and 6s up, did we get 2,520?
No.
Why? Why do you? Oh my heart, friends, let me talk. Why do you think those numbers are different, Michael?
because there was some miscalculation somewhere.
What kind of miscalculation? What kind of mistakes do you think might have happened, Audrey?
We might have rolled too less.
Yeah, we might have rolled too many times or not enough times. Some people might have added incorrectly because these are bigger numbers. And is it easier to make mistakes when we're doing bigger numbers? Emmeline?
If we were doing the fours, you might have said your fives answer.
Yep, you might have said the wrong answer when we were saying it. You might have said the fours answer instead of the fives answer.
I didn't roll
Tegan was gone when we did it.
Evan was here when we did it. He's gone.
Oh, so that's a good point. Thank you, Priya. Evan was here when we did it and he was gone, so that's going to skew it by one person's results. I didn't realize that one. I remembered Tegan was gone. Yeah. And someone, like Evelyn's saying, she's like, you know what, I just added up my numbers and I was short a couple of rolls. It happens. Because when we're rolling 120 times, it's really easy to make that simple mistake.
Actually, I think I was wrong because we didn't do this yesterday. Because the day we did do it, I think he was here. We left yesterday.
I got the same number.
Yeah,
that's
the
the
thing.
thing.
He needs.
Oh.
No, actually,
He doesn't need to be here.
oh, I don't remember. I would have to look.
He
So-
was here.
So that skewed it a little bit because we had one person here who's not here. So if we added in, let's say we added in 120, right? So, or let's subtract 120. No, not 120.
That will give us 600.
400.
Okay, so now I'm having to do math on the spot. So if Evan wasn't here, we theoretically would have rolled each one 400 times because we take out his 20, right?
Then the average
Is that
was
right?
401. That's really close.
Did I do that right?
I have a feeling probably.
Would it say to be 122?
No, because it's saying how many each number is rolled.
So if we made
So each number was rolled 20 times. So we would take 20 out. So it would be 400. Thank you, Hugo. So theoretically, without Evans, we should have gotten 400.
Wait, so which number are we?
So with our results that we got, we had to subtract from our theoretical. We had to subtract that 20. So now it's out of 400. Still going to be a bigger difference than what you saw with your results.
No, the average was 401. For those. I'm saying the average.
Oh, I see what you're
So we
saying.
were actually pretty close.
Okay.
We were pretty close on average.
Oh, so Hugo, tell the class what math you just worked out.
The average was 401.
So if we add up all 6 of these numbers and we take the mean, that average, we divided it by the 6, we got 401. And we needed, our theoretical was 400. So now which one is closer? The class instead of your own. So if you were to add up all 6 of your own numbers and divide it by 6, what is your average? We want to see how close you are to 20. Our class was at 401, which is really close to 400. You had exactly 20?
Yeah.
Exactly. Divided by. Oh, it's just 120 divided by. Oh.
So,
It's just 120 divided by 6. Oh.
so here's why. Here's why we can't go by our averages. So Hugo was thinking, oh, I'm looking at the probability, but I switched to averages. Is average the same as probability? No. So we got a 401 here because a few people made a few mistakes. Like Evelyn said, she made a couple of mistakes. So it should have been, the average should have been 400, and that would be the theoretical probability of 400. So we can't go by averages. But it was a really good thought, but that's the reason why we can't take the average for the probability, because they are two different things. So let's see what it is that we needed to have learned from this. Because we're not just going to do our average. We need to talk about that law of large numbers.
I know 2 and 4 because the reds are blacks and
Okay, I'll get that. So the law of large numbers. You need to write this down. The more times you do something, the closer the experimental probability gets to the theoretical probability. So we got a little bit skewed because we had somebody not here, and so we forgot to take that into account. If we went back to that heads and tails, we would have seen it would have gotten a lot closer had we added everybody's in, because we did have those 6 people who got 25 and 25. So if you were off 18 and 32 and you factored in the people who got 25 and 25, that brings yours closer. So actually bringing it in closer for the majority of us who were off from that theoretical probability, factoring in the people who got it closer, it brings everybody closer to that theoretical probability. So in reality, when there are a larger number of results, you get closer to that theoretical probability. So some of us hit it right on the money, but the majority of us did not, right? There were a few of us that got lucky. Most people don't get lucky like that. But as we factor everybody in, it gets closer and closer to that theoretical probability. That's why we want a bigger sample size. That's why we want a larger number in our experiment. So we get closer to that theoretical probability. So our little bit of homework that we have for today says, use the spinner below to determine if the result is above, below, or equal to the theoretical probability. So in your workbook, that red looks really dark, so you can't see that that's a 1 there and a 3 here. So make sure you know that it's a 1 and a 3.
And the color too.
So this is red. And this is red. This is yellow. And this is yellow.
Why is yours colored and ours colored?
Because when we print in black and white because color ink costs a whole lot more. So mine isn't printed out in color. That's just on the screen. My book, it's printed out in black and white also. So printing out, we're just saving the school money by not printing out 25 colored pages for everyone. Michael.
Just black and white ink is pretty expensive.
Yes, it's not as expensive as color. So look at what we have to do. You take 12 spins and you get 4 2s. You take 10 spins and you get 3 yellows. You take 32 spins and you get 10 1s. You take 250 spins and you get 120 odd numbers. Okay, so when it says odds, that's odd numbers. You take 1 spin and you get a 3. What is the theoretical probability of doing those? We are not going to do the experimental probability because I don't have 25 spinners for us to use. We are just doing the theoretical probability. And you're going to write, so first you have to think, what is the theoretical probability? we're telling you what results you would get if you were to do the experiment. We're saying you get 12 spins, you spin it 12 times, and 4 of them become 2s. So what is the theoretical probability of doing that? So you're going to use the results to see if it's above, below, or equal to the theoretical. So what's the first thing we have to do? Aiden? We have to find the theoretical probability. So what is the theoretical probability for spinning a certain number?
For 12 spins, you'll get 3 of each.
For 12 spins, you should get, because there are 4 numbers, you should get 3, 3, 3, and 3. So you should spin the 1 3 times, you should spin the 2 3 times, you should spin the 3 3 times, and you should spin the 4 3 times. So if you take 12 spins and you get 4 2s, is that above, below, or equal?
Above.
It's above. So you're going to write above.
Wait, what? What was that part?
If you spin it 12 times and you get 4 2s, if this is our theoretical,
I was like, why did you get above? I thought it was below. I read 2. I read it
we
backwards.
get 4 2s.
I read it backwards.
Yep.
And I read
That's why I
2.
wrote down.
That's why we went through it together. So go slow, figure out what the theoretical probability is, then figure out what they're getting. Is it above, below, or equal to the theoretical? For my friends at home, we hope you are well, and we hope to see you soon. Chance?